this video, when and why to use MariaDB key features in 10.0 to 10.5. Now, if you know anything about MariaDB timelines, you might be wondering why on earth am I talking about MariaDB 10.0. And 10.0 was first generally available back in 2014. It's already reached end of life back in 2019, so why go all the way back into ancient history? Well, it comes from an ongoing observation / joke inside MariaDB that we're not very good at letting people know about all the new features that we have. And in fact, there was a fairly recent case of somebody not realizing that MariaDB 10.0 has had roles. So MariaDB has had roles for the last 6 major releases, and that still not everybody knows about. So this talk is an attempt to overcome that and to fill the gap. What it's not going to be, it's not going to be in depth. It's only half an hour, so it can't possibly cover all of the topics that I'm going to mention in any kind of depth. I will be linking to knowledge-based articles and YouTube video channels so you can see for further details. And it's certainly not going to be complete either, because a blow-by-blow account of every single new feature added in 10.0 all the way to 10.5 is not going to be very much fun to watch, and certainly not going to fit into half an hour. What it does aim to cover is interesting features that perhaps you may not have heard about, and in particular features that differentiate MariaDB. I mean, people often see MySQL and MariaDB as the same. Usually if a feature is in MySQL, more people know about it, but this talk will then introduce you to some features that might not be in MySQL as well, or might not be in other databases, so that you've got less chance of having heard about them. I'm going to be speaking very quickly. As I say, only got half an hour. We're racing through it, a very high-level view, but there will be links in the slides to knowledge-based articles where you can follow up to get more details for yourself. So let's start with storage engines. Now, storage engines are the underlying architecture, if you will, of the database, and by default MariaDB uses the InnoDB storage engine. It's great for general purpose usage. Most of you won't have to worry about or even think about changing it. A lot of work has been done on improving it. In 10.5 in particular, there's been a lot of performance improvements made towards InnoDB, and it works really well as the default. It's very well tested and so on. But there are other storage engines that perhaps are of interest as well. So here's a couple of them listed and the versions that they were introduced. As I say, I'm going to give a very high level overview, not going into any kind of detail at all. So the first one is MyRocks. Now MyRocks, there's a talk by Mike Benschoof, MyRocks, a 30,000-foot view, actually here at Percona Live, so you can watch that for more details. All I'm going to say about it now is compression. If you need better compression, MyRocks was originally written at Facebook, optimized for flash storage, better throughput in that kind of context, so that's where you would want to get the benefits of MyRocks from. And there's more details if you want to read about it on the knowledge base. Now, that doesn't mean that the regular InnoDB storage engine doesn't have any kind of compression on its own. It does. In fact, rather confusingly, it has 3 types of compression. And the first is the very old compressed row format, which has been around since very ancient history. You would create it in the following way: create table, and then a row format equals compressed at the end of your create table statement. Slightly newer version is InnoDB Page Compression, which came around in 10.1. You can see create table here, and page compressed equals 1 is the way you use it. And you can activate that as well by default by setting InnoDB compression default in your config file, and then by default, unsurprisingly, all InnoDB tables will be compressed, making use of page compression. Now it's confusing because why would you use one over the other? Well, the first thing to notice is that there's a move towards deprecating the compressed row formats. It's not deprecated yet. 10.6, the upcoming development release, has made it right only by default, but it still works, it's still usable. But at some point, the plan is, in order to simplify and optimize InnoDB further, is to remove support for the compressed row format. Other differences, the way it's stored in the buffer pool. Compressed row format stores both the uncompressed and compressed data in the buffer pool, while the newer page compression only stores the uncompressed data. So that makes the difference as to when the compression overhead is going to have to take place. With the newer format, you only need to do that before writing, or when writing to the table space. Otherwise, in the older format, you need to do that after every single change, because it's inside the buffer pool. So that should give you some idea that if you are starting to use compression for the first time in a new project, compressed row format is probably the way to go, given those two choices. There's a third format available, which is storage engine independent column compression. Of course, it's not only available to InnoDB, as the title says, as the title indicates, and it's got a slightly different use case in that it's specific to a column. So you can leave the rest of your row completely not compressed, no need for it, no need for the decompression overhead. You just want to target it at a blob or a text field, perhaps, that can make really good use of being of the compression. So it's that's your main use case difference: general usage versus targeted at particular fields like blobs and texts. A couple of other minor differences is that storage engine independent compression only has the zlib compression algorithm available, while compressed row format has alternatives. There is some work going towards simplifying and reducing perhaps the number of compression algorithms available, because having too much choice isn't that useful if there's no use case for them, but that's ongoing work at the moment. This is the situation. Storage engine independent compression also doesn't allow indexes on your compressed field, where compressed row format does allow the usual indexes. So those are the three types, and there's your knowledge base link if you want to read a little bit more about them. The next storage engine is Spider. Spider makes use of partitioning, supports XA transactions. Its real use case is that it allows you to access tables on different MariaDB instances as if they were a single table sitting on the same instance. So it really makes all of that kind of connection between different servers transparent for you. That's been available from 10.0, and again, you can read more about it there. I'm not going to go into it in any more detail for now. The Connect storage engine is one of my favorites because it's a kind of sticky tape of storage engine. It allows access to all sorts of different formats and makes them usable within MariaDB. So this is the list of formats here. There's a whole lot of them. It's really, I think it's a great storage engine. Here's an example of using it for the DBF format. You have your create table statement. You specify the engine as Connect, and you just point it to the right file name, and Connect does all the rest of the magic. Here's an example of a CSV file. Now, if you know MariaDB or MySQL in the old days, you'll know there is a CSV storage engine. It only works on CSVs. Connect is preferred now because it does it better and has much more functionality than the old CSV storage engine. So there's not really much reason to use the old storage engine anymore. Connecting to your CSV is as simple as this. Engine equals connect. You specify the table type as CSV. That's the magic in connect. Give it the file name and your separator character and your header. There you go. You can access your CSV within MariaDB very, very easily. You can even do so if it's in a zip file. Same definition as above. You specify it as zipped, and you have an option list pointing to the particular file. So this is an example that would work if the zip file has multiple files inside it, and you only are interested in one of them, which is the CSV file. You can extract that single CSV from a zip containing lots of other stuff as well. And here's an example of, again, a single zip file containing multiple CSV files. It's the same except that you have a wildcard after emp. So this would work for the format emp1, emp2, etc. And bring them all in, access them from within MariaDB. Very easy. You can read more at the knowledge base. Then the S3 storage engine. So this is was added in MariaDB 10.5, and it's really an archive storage engine, read-only, useful for storing data in anything that implements the S3 API. So Amazon S3 itself, or any of the multiple public and private clouds that do so. That's been around since 10.5, and you can read about it there. Galera It's not really a storage engine, it's a clustering solution. It's been part of MariaDB since 10.1. Before that, you would have to download a separate Galera install for 5.5 and for 10.0, but since 10.1 it's been built in as part of the core MariaDB server. It allows you virtually synchronous multi-primary clustering. Great solution, but again, worthy of multiple videos, multiple presentations on its own. You can go and read more about it, the knowledge base, or watch some of the YouTube videos on the MariaDB Foundation YouTube channel. Now, temporal tables. So temporal tables are made up of a number of subsets. One of them is system versioned tables, which was introduced in 10.3, and that allows you to query historic data. And then there's application time periods, where you can query on a particular temporal range. That was introduced in 10.4, and there's also bitemporal, which allows you to a combination of both of them. So here's an example of system versioning. This is based on the SQL standard. You would create a table, you would specify a start timestamp and an end timestamp, the period, and you would specify with system versioning. And MariaDB has a shortcut here. You can just use with system versioning, and all of that stuff is hidden from you, and it also is then hidden from cluttering up your table definition and so on when you view it. Here's an example. So you want to select star from the table at a particular time. So now let's assume, give a use case. Let's assume that someone's come in, maliciously wiped your data or run a terrible update, it's done something horrible, you don't have it anymore. So system versioning allows you to view the data inside the SQL layer as it was at a particular point in time. So I think that's quite a fantastic feature. MariaDB was, I believe, the first open source database to introduce this as part of the core server. It's a really great and underutilized feature, I think. And querying it is very simple. You would specify as of a timestamp that you're looking for the data at, and it will bring back the data as it existed at that point in time. You can also do it for a period, so if between, say, now and a year ago, same thing applies. Application time periods, as I said, it allows you to query over a particular period of time. So you would want to create your table here with a date 1, a date 2. By default, it creates a constraint so that date 1 has to be less than date 2 in your time period, which makes sense. And here's some sample data. Now, given the sample data, let's see what happens if we run a delete statement. Now, here we go, we delete for a portion of the date period from 2001 to 2018. So note that the dates here run from 1999 to 2019. We only want to delete the portion from 2001 to 2018. So what happens when we do that? So record A, after the delete statement, record A remains unchanged because it fell entirely out of the portion that we're trying to delete. Record B overlaps at the beginning and the end. So what happens here? Record B actually gets split into two. The first record is from 1999 to 2001, to the beginning of the period. Everything between 2001 to 2018 as per our delete statement is deleted, and it's now split into a second record containing the remainder, which is 2018 to 2018 12. And records C and D, C overlaps at the beginning of the time period, so everything after 2001 is chopped off, and D overlaps at the end of the time period, so everything after the end of everything before the beginning of 2018 is chopped off as well. So that's application time periods. We can look here at a basic example and also a potential downside of the way that we used at the beginning. So here is a booking system. We have rooms, we have a room number, guest name, check-in date, etc. So again, check-in date will automatically be before check-out date. That's a given constraint. Now assume you want to insert this set of data here. You've got room 1, and this is also making the assumption that there's one guest has one booking for one room at a time. So you can't have multiple bookings for a particular room. That's an assumption I'm making. Now, room 1, you can see the guest comes on the 1st, leaves on the 3rd. The next guest comes on the 3rd, leaves on the 7th. No problem there. In room 2, we've got a guest that arrives on the 2nd and leaves on the 5th, but another guest that arrives on the 4th. Now, we don't want this. This is not valid according to the way we've defined it. So, MariaDB 10.5 includes another clause here, which is the without overlaps. You can specify that you are not permitting overlaps in this context. Here we go, unique, it's based on the room number, unique room number, so room 1 and room 2 are separate. Specify without overlaps, and in this case your insert statement will fail, duplicate entry. Exactly what we want. So that's without overlaps introduced in MariaDB 10.5, and you can read more about temporal tables there in the knowledge base. Moving on rapidly, Flashback. So Flashback allows databases, tables, your instances to be rolled back to a point in time, a previous snapshot based on the binary log. So at the moment it's only for DML, so your insert and update statements. A future version will will implement that for DDL as well, so you'll create and alter statements, and that's been available since MariaDB 10.2. So again, it's great for restoring something after something has gone wrong. It's restoring your data after something has gone wrong. It requires binlog format row and binlog row image to be full, so it's available to all storage engines. That would be in your config file. Then you would run MariaDB binlog, and for those of you not aware, since MariaDB 10.4, all of the old binaries, MySQL binlog, MySQL client, etc., a symlink was created so that there's an equivalent MariaDB version. So there's a MariaDB binary, there's a MariaDB binlog binary, and these are some symlinks to the MySQL version. And from 10.5, that's actually been reversed, where the actual binary name is now MariaDB binlog, but the old MySQL binlog is still maintained as a symlink for compatibility purposes. So this is how you would do it. You would access it through MariaDB binlog, specify the binary log, you put a database and a table, and you can give a start date time, or you can give a particular period in the binary log as well, a particular point in the binary log if you want to, if you know where it is. The -- flashback is where the magic happens. That tells you, it tells it to go back at that point in time. In this case, I'm exporting it to flashback.sql, and you can just import that into your database, and you've got a flashback, a snapshot of the data as it was at that specific point in time. So very simple to use, and also fantastic functionality in case of problems. Then some SQL syntax moving along. We've got if exists and if not exists. Now, they both are intended to give a warning instead of an error in certain contexts. They've been around since, well, consistently implemented since 10.1. Before that, they were around, I think, for a few statements, but since 10.1, pretty much every statement that it's applicable to will make use of them. Here's an example. If we drop user Bob and Bob exists, if we drop user, that will give an error because we're not able to do so. Sorry, the user doesn't exist, of course. We can't do so. If we say drop user if exists, the statement doesn't give an error, but we only get a warning telling us that it doesn't exist. So reduces the amount of noise. The same applies for create table. We assume create table exists. We run the statement. No, it's an error because it already exists. We can run create table if not exists, and no error message. We simply get a warning telling us that the table did exist. Similar is the or replace statement. Again, just making life a little bit simpler when you're doing your SQL. Or replace will automatically create, drop and create rather than giving an error. And it's been available since 10.1 as well. Giving an example from the past, we've got create table T2, it already exists, so that gives an error. Now we can do create or replace, and no problem. If the table exists, it will be dropped and it will come back. If it doesn't exist, created as normal. You can read more about it in the knowledge base again. Next one is returning. So returning will give a result set from either the delete or the insert or the replaced data. Delete returning has been around since since 10.0. Insert and replace have been around since 10.5. Quick example here. Create or replace table. Now we insert some data, and at the same time we can return that data and use it. And an example I've given here, you can see I'm only inserting an ID. The T is a timestamp, automatically inserted. So we can, even though we're not inserting it, we can return it at that same point in time and get the timestamp back. So very useful to simplify your SQL. And of course it works with delete and replace as well. Here's what would happen if we did a delete returning. So read more about it on the knowledge base over there. And then we move on to Oracle mode, so Oracle compatibility. MariaDB 10.3 introduced a rather large subset of Oracle's PL SQL, implemented some Oracle syntax, some Oracle functionality. Some of that functionality will only work in Oracle mode, and others are functionality that then works in the default MariaDB mode as well. So it's not just a benefit if you're trying to migrate from Oracle. To activate it, you would set the SQL mode equals Oracle inside your config file. Now there's lots of differences between Oracle and MariaDB, so this doesn't go into them in any kind of detail. There's a lot of complexity to it. Just a couple of things. Here are some synonyms for basic SQL type. Your varchar becomes your varchar2 in Oracle becomes a varchar in MariaDB. Date in Oracle has a time portion, or can have a time portion. If it does, it will become a date time in MariaDB. And there are others, raw, etc. as well. Here's an example of behavior that's different. So the same function will give different results depending on whether you are in Oracle or in regular MariaDB mode. And the example here is the length function. So pi, the character pi, is a multi-byte character. If you do a select char length, the number of characters, you'll get a result 1. And if you do a length b or octet length, looking for the length in bytes, you will get the result 2. The difference is in the length function. Length in MariaDB gives you the byte length, while length in Oracle gives you the character length. So depending on the mode here, you will get different results. Then you get sequences. Now sequences are a new feature. They were added primarily for Oracle compatibility, and they allow you to, well, an object that generates a sequence of numeric values. And you use them as follows. You can create a sequence starting with 100, increments of 10, and then access the next value, the previous value, and so on. An example will be selecting next val s. You can also use alternative syntax, selecting next value for s, and there's the alternative Oracle only syntax, not standards compliant, so it only works in Oracle mode, which is select s dot next val. Okay, so Oracle mode, it's fantastic in helping to migrate from Oracle to MariaDB. If you look on our YouTube channel, there's some great case studies of organizations that have moved from Oracle to MariaDB. In fact, there's a great case of an organization that was running Oracle database, didn't have access to the source code anymore, but in spite of that still managed to do a successful migration to MariaDB using Oracle mode. So it took a bit of work, but it is possible. Oracle mode, of course, isn't a complete, absolute rewrite of Oracle, but in the vast majority of cases it makes migration very easy. And there's going to be further updates in 10.6 as well, which my colleague Vichensu will be giving a talk on new features in MariaDB 10.6 at Percona Live as well, so please watch that for the new features. You can find out more, look at our knowledge base, look at our YouTube channel for some videos, or you can join us, the developers and others, on our MariaDB Zulip chat instance. So thanks for watching and enjoy the rest of Percona Live.